Now the bottom one is 50 gram and the next one is another 50 gram. So always you have 50 gram masses are available. You can add one by one to this. So that means what is the meaning is, if I am going to attach now 50 plus 50 is there now. 100 gram is attached. So because of the zero friction, this particular mass will descend down, it will come down, and therefore you will be able to see the rotation of the flywheel itself. We can see this. So whenever this particular tape comes in front of your eye, then you say that 1. Okay, then once again if it comes to the same place, then you say 2. Like that you have to count. So let us see it is now rotating, and therefore you can see that once again the tape comes to in front of you, then you say 2, then it is coming once again here, now it is say 3, 4, etc. So when it is falling down, the speed will increase. You see how many times the tape is coming. Now it is, the tape is coming quickly, right? And therefore it is rotating fast. And finally that mass will fall down on the floor. You see that this is the mass. So mass is now falling down on the, now the mass has fallen down, and only this is now this is still continue to rotate. So therefore this is the ground level. So from the ground level, now this is at a certain height. So that height is the potential energy. So therefore this particular mass is having m into g into h, potential energy is there. That is why we are worrying about 50 gram or 100 gram. Okay, so that potential energy is now attached and then it is staying at this particular point. When you are releasing the hand, now we are holding it here. Now you have to release the hand. The moment you release the hand, it starts coming down, which means that what is the meaning is that the potential energy is decreasing. You see, when it is coming down, what is the meaning? When it is coming down, m into g into h. H is reducing, right? H means height from the ground level. That is reducing. That means potential energy is reducing. That means what is the meaning is that your total energy is reducing, means that energy is transferred to the wheel. See, the wheel is rotating, right? This wheel is rotating means the wheel is now gaining kinetic energy. So ultimately what is happening is that any reduction in the potential energy has been transferred to the wheel as kinetic energy, so that the total of the kinetic energy plus potential energy remains constant all the time. Okay, so when you are going to perform the experiment, as you can see that all the potential energy is getting transferred to the wheel, and therefore all of them is getting converted to the kinetic energy. That is why the wheel starts to increase its speed. 2 pi r is one round, right? So if you are going to make 50 rounds or 40 rounds, for example, then 40 into 2 pi r. For that 2 pi r, I need radius, right? For that you take a vernier caliper and then do the measurement. So that is the part that you will be doing in actual practice. When you are doing in the lab, this measurement you will be doing. Let the stop clock run, okay, and you make how many turns it is making. 1, 2, 3, 4. It may be revolving for 120 times. It may, this, because this will not stop easily. See, this rotation will keep on going, and now your stop clock will be continuously running. You allow the stop clock to run until this flywheel comes to stop. So this will take some time. Okay, it will not stop so easily. Once this particular wheel comes to end, then you immediately stop the stopwatch and then note down what is the time shown by your clock. Now as you put more and more mass, what will happen, you can imagine that this particular wheel is going to revolve very fast, and therefore counting will be difficult. So initially you'll be counting like 1, 2, 3 like that, but once you are adding 7 masses, the counting will be like 1, 2, 3, 4, 5, 6. That much fast you have to count. Counting has to be done by you manually. Then all the data you are going to collect and then write it down in the form of a table or column. So that's all about the measurement. Once you finish the measurement, you can come to the last. This is the last formula that you have. That's also in this formula you're going to substitute all the quantity that you measure, where the m is the. We will see what are the these variables in tabular column. It will be easy. Let us first go to tabular column. Yeah, here it is. So you are going to do the measurement like this. As we know that you know how to start. Minimum is 50 gram. Less than 50 not possible. So 50 gram first value, second value will be 100 gram. So you are adding 50 gram every time, and then this is only a sample. See, 1 2 3 4 5 6, 6 are there. That doesn't mean that only 6 you have to do. This particular is a schematic representation. That's all about it. So if you are going to have more number of masses with you, then that many mass you have to do the experiment. You should not stop, because tabular column has come to end. Okay, this is the schematic representation of tabular column. So if you are going to have 10 masses, then you have to put 10 lines here. Okay, that is one thing. Second thing is, there are two things that you are going to vary. So therefore, the number of rows will be very high. Okay, so what is that you are going to vary is this height also you are going to vary. So when you are going to vary mass and height, then you know how many variations are there. Lot of variations are there. That means for 50 gram alone, remember, for 50 gram, second line also 50 gram, third line also 50 gram, all of them are 50 grams, whereas height will change. The height will be like 40 centimeter, 30 centimeter, 20 centimeter, 10 centimeter. So for 50 gram itself, you have the variations here, because this height is there, right? So that is the one that you are varying. 50 centimeter you can keep, finish the experiment, then make 40 centimeter, finish the experiment, 20 centimeter, finish the like that you can do the variation, and that variation is allowed from the top. This is a schematically it is shown here. You have to you have seen the video, right? You have to go all the way near to the axle. From there you start doing this variation. So at least you can do the variation for 4 5 different heights. So therefore, you are going to vary not only the mass but also the height. So therefore, for 50 grams, all the 5 variations in the height, 100 gram, once again 40 centimeter, 50 centimeter, etc. Then 150 gram once again. So therefore, the number of rows that are coming here will be more and more. So you have to add additional things. Okay, these are the initial starting. What are you measuring? You see, what are you measuring is the number of revolutions. Actually, number of revolution is only capital N. This N is not the number of revolution. Okay, but somehow they have typed like this. So this point you note down, otherwise you'll confuse. Capital N is the number of revolution. Number of revolution means what? How many number of times the white color tape is visible to you when it is revolving. Okay, that number is N, capital N. You write down. But small n, what is the small n is? Small n is the number of times you put the thread there. That is only small n, not revolution. Okay, so this is the number of times the thread is there when you are starting the experiment. This is the total number of revolution after, remember, it is after releasing of the mass. The mass will fall down, right? The moment you'll have to remember, the moment the mass has fallen down, from there you have to count 1 to 3. That number has to be written down here. And when you are counting, the stop clock is measuring the time. Okay, so you are going to have a stop clock, right? That will show the time. That time you write down here. So there are these are the things that will go simultaneously. These measurements are static. That means it will not change, right? Once for all you fix 50 gram means always 50 gram will be there. Now what will be going dynamically is keep on changing is the number of revolution. You have to be careful. You have to continuously see the flywheel and then count it so that you don't make a mistake. Similarly, you'll have to stop the clock immediately when the flywheel comes to rest. So these are the two things that you'll have to take care. And once you finish this, and that's it. The rest of the thing is only calculation here. Okay, so it is only the number of times that you are going to repeat the experiment for various masses, for various height. Okay, only time consuming, and little bit, you have to be very attentive. You have to pay attention, because you can't turn this side, that side, because this wheel is going to rotate fast, and therefore you have to pay attention and then make a note of the number of revolution. And once that is over, and I think that is over. Once that is over, you all bring the numbers here. Okay, and then put it into this particular formula. As you can see that m is the mass of the load that you put in. Okay, of course all numbers should be in SI unit, and only thing point to be noted is that the small n is the number of thread that you are going to add there, and this n is the number of revolutions. and height that you are going to measure every time, and omega will be calculated. Omega is you are going to calculate from this tabular column, because you have the number of revolution, you have the time, so you can make this formula and then convert it into omega. So once you get this, the final answer, you forget about these units. Okay, these units will come naturally depending on what you substitute. So when you substitute all values in the SI unit, this also will come in SI unit. So writing down this kind of unit uh, without any number is no meaning. So delete them. So whenever you put the number, at that time you worry about the dimensions. Okay, this is one thing. So this is one piece of information that was available in the internet, where the video was, I am able to show at least for this. Okay, if I'm not showing the video and showing only this photograph, it will be a little difficult. You don't know which one is rotating, etc. And in this case, you see red color tape is fixed. Okay, it's just whether it is red color, green color, or white color, doesn't matter. Some kind of marking should be there. Okay, then only whether it is rotating or not. That's fine. That And in addition to that, interestingly, there is one more piece of information is available, okay, online, wherein you can actually see how the rotation is taking place. That also I will show you, so that it will be more comfortable. So where is that actually? I think this is the one. So this is another piece of information available somewhere in the internet, where the actual experiment is written in some kind of Java program. So it looks like a simulation, right? So everything is done here. So here the stop clock is shown here, the bottom. This one is the stop clock. Okay, so that is the one. And millisecond you forget. Hour, minute, second is okay. Millisecond part, it will run very fast, so don't see that. So we are interested to count only minutes and second. Okay, that is one thing. Coming to this, actually this meter will not be there in the experiment. In a real life experiment, this meter will not be there. Actually this meter is nothing but counter means it will count how many times. So no, 1 2 3 it will count, that's all. So actually you have to count it in the real life. Because it is a simulation, so the counting is also done by this kind of setup. So they have written the program that once it makes one round, then automatically one will come here. So that is the idea. And then here you can see a small line. Of course here a little difficulty, they could have put a bigger tape like that, but here you see, can you see a small line at least? Some small line is visible, right? So that is what is the line that you have to worry about. Whenever the line comes in front of you, you have to say that 1 2 3. Okay, that 1 2 3 will be recorded here. I mean, in a simulation it is actually. So this is how it looks like. And then you are going to measure the height of the mass from the ground level. So this is a schematic representation for the scale. So you have kept the scale vertically, so you can measure the height. Okay, that is the idea. So now here you see that in a real life you can fix some of the values. So as you can see, 5 kilogram is kept here. Diameter of the flywheel is 10 centimeter, and you are going to start the experiment with the 200 gram of the mass. And so all the things are there, and how many number of times you are going to wind it. So here right now it is 1 is there. You see, so I'll increase here, and that should be visible there. So now can you see that 10 times it is wounded, right? Something should be visible better. So now at least some visibility is there, that 10 times winding is there, so that the mass has come up like this. So whatever is being done in a real life, they have written in a programmatically in some program. So that is how it looks like. So once this kind of apparatus is there, okay, now I think let us go back to the original size. Okay, so now the advantage is that you will be able to, let us start with something like 3. Okay, only 3 or three rotations are there on the thread. Now we can start the experiment. That means release the flywheel. So if you release the flywheel, you see that it is falling down. You have to see here, this one is falling down, and then thread also fell down. But this wheel is continuously rotating. Each time you count it, that counter is there, 13 count, 14 count, etc. And time is also running. This number you have to keep on counting until it stops. So this is the place where it takes some time. So let us wait and see when it stops. The flywheel has to reduce its speed slowly because of the less friction, and then it will stop after some time. So once the flywheel stops, you have to stop the clock also. So the stop, you see the clock now, this particular clock that will be stopped automatically. Okay. So now the moment it stops here, that's all. So I didn't stop it actually, because this is a simulation, right? So they have written the program in such a way that whenever the flywheel stops, this particular clock also stops. But in a real life experiment, you have to press the stop button in the stopwatch. Okay, now that you have these numbers, right? 1 minute is there and 11 second is there. Forget about millisecond here. Similarly, zero point 0.4 and all not possible. In real life, you cannot measure zero point 0.4 revolution. One revolution, two revolution only you are going to count. Therefore, you have to write down 61 revolution. That is what you have to write down in your tabular column. And you have to write down 1 minute, 11 second you have to write down. And those numbers have to be written down for the remaining numbers here. Axis is 2, mass is 200 gram. For that kind of combination, this number has to be written in a tabular column. Now you can repeat, as you can see that this particular simulator has the ability to repeat it. So okay, press the reset. Now if I put the reset, this 1 minute 11 will go to 0, 61 will become 0, and this particular mass and the thread has fallen down, right? Again it will go and it will go here and then uh, start, as you can see. So this one you have to do manually. Okay, you have to once the thread falls down, you have to take it, and then there will be a very small hole inside, and in that you have to put the thread and then tie it there slightly. It should not fall down initially, but when the mass is completely here, then at the time it will automatically come out. So you should not tie it tightly. So that is there here. And as you can see, 200 gram, 400 gram, you can always, this is 400 gram and that will be 600 gram. So when you are going to have large mass and then you are going to attach this and then you start the experiment, this particular thing will fly, or we say that it will rotate very fast, and therefore these numbers will be large. Last time you got 61, right? Now you are supposed to get more than 61. That's the meaning, because large mass is there, right? So automatically you can see now 68 has already come. So automatically it will take more number of revolution, more time, everything will come. So that's all about it. So this is the experiment. So I'll stop here. Stop. So once this is clear, you now know what to do. You have to fill this particular tabular column. So you fill it, you fill out this for possible values of all possible values of mass and allowed values of the height, etc. And once you have this, the rest of the thing is this calculation. So that's all about the experiment. And coming to the giving the marks, finally, finally what is the conclusion is that we have to provide your grade, end semester examination. We can't conduct the end semester examination, you can't have, you can't touch the apparatus and do, that is the situation. So for in order to make some kind of evaluation and give and provide some marks for you, what you have to do is how to gain mark. So you have to get some grade, right? For that, now this is the work that you have to do. The work you have to do is you have to now fill this table. Okay, you repeat you do the experiment and fill the table, do this calculation, and then what is the moment of inertia that you are getting, do this calculation, and then as usual you write aim apparatus. Of course here writing aim apparatus is easy, it's already there. You write down aim and apparatus, and then draw the tabular column in your take a white paper and do all these things. Okay, and then do the calculation. In this experiment there is no graph, Okay, so no need to worry about graph. So fill this data. This is your work now. You finish this calculation, and then uh, if you're having 5-6 pages, it's okay. You take the snapshot photograph, convert to a PDF file, and then submit to us. So once you submit, so that will be counted as some kind of evaluation. So without anything, we don't know how much mark to give, isn't it? So in order to provide, so now only Uday Nidhi is joining. Okay, so only based on this, we will be able to provide some grade for you. Okay, that is the reason. So this is, don't take it lightly, because based on this only your final lab grade will come. So do some work and then fill with these things with numbers, and then do the calculation, take a calculator and do, and then submit it. So typically one experiment we will consider it as 10 marks. Okay, 10 marks. So if you are going to do 7 of them, let us assume 7 experiments if you are going to do for this mechanics lab, then 70 marks. So 70 marks will be the maximum. So out of 70, how much you got? If you got 65, you can convert it into a percentage, and that will be awarded for you as an end semester grade mark. You understand? So that means we are not going to conduct something like final exam. For the time being, that is the plan. If there is anything like Viva exam, of course, you know that there is something like Viva examination. And for that, we may conduct that, we will discuss later. Okay, so there is something like up to 10 marks is there for Viva examination. So therefore, if it is the case, we will ask you questions like Viva exam means what? We will ask questions like define moment of inertia, um, and then they will ask you some kind of small question saying that how the moment of inertia is taking care of the conservation of energy. Okay, that this kind of questions will come. So they are all small questions that you'll have to answer. So that will take care of 10 marks for totally 10 marks for all the experiment. Okay, so out of all the experiments, some questions will be asked like this, so that it is easy to answer for you. That will take care of the 10 marks. And any lab calculation that you are going to do with the tabular column, graph, etc., that will take care of the 90 marks. So 90 plus 10 is there. Finally, that will be converted to 100, and we can give the grade. So that is the idea. So you, if you have any doubts or anything, you can ask now.
Sir,
Yeah.
sir, during the final examination, we will be given the observed values, or we have to find at that moment itself, sir.
Not at that moment. Now there is nothing like final exam, and you don't have to wait until that. Now see, once one experiment is over, today I am doing this experiment. I don't know, last class Professor Ramesh Naidu or somebody else might have finished already 1 or 2 experiments. So the moment you finish the experiment, that means your explanation is over. You for this apparatus, I will give you the link to you. Okay, where the simulation is there. So you can use the simulator and then fill the numbers here. If the simulator is not available, of course, for every experiment you cannot get simulator. It is available, from third party. So when it is not available, what we will do is we will provide you some numbers here to fill. So that means m will be given, h will be given, small n, capital N, and time. All the measurements that will be done in the laboratory, this number we will give it to you. Then what you have to do is you have to do whatever calculation part is there, that you have to do using this particular whatever formula for that experiment. And finally, you'll have to make the conclusion saying that the moment of inertia or whatever experiment, for that experiment, what is the conclusion that you have to write down. And that's all. That is the one which is going to give you the marks. Okay, any now ask the question.
Sir, the total marks comprises of 7 experiments, which is of 70 marks, and 10 marks for Viva, right?
Yeah.
So the rest 20 marks.
Hey, no. It's only conversion. No. Not like that. See, total is 100, right?
Yeah.
Total 100. So what is the idea is that The originally how the experiment is in real life, you are now okay. You have not done even one semester, right?
I didn't get
Yeah,
you.
okay. No. Your seniors means they will be having idea how they are doing. Okay, for you it is first time, right?
Yeah, yeah.
Okay. So usually, what is the idea? How a regular day, if you come to the lab itself, what how we will be doing is that we will conduct the examination for only 25 marks, and 75 mark will be record. You have to write a record, right? In the school, you used to write, right? Record note will
Yes,
be
sir.
there. So that record mark, 75 marks will be given. Final exam will be conducted one day, like a final university exam. That examination, 25 marks. So this combination we will give 100. That is how usual days we will give. Now what happened is, now final exam like thing we can't conduct, isn't it? Theory means okay, we can conduct, lab we cannot conduct. Therefore, the plan what we are going to do is that instead of doing the one day examination, you whatever you do for the record work, right? This is called record work, writing the numbers, doing calculation, and that's your record work, right? Based on your record work itself, we will convert it to 100 marks and give the grade.
Okay,
Converting,
sir.
you got the conversion. Let it be 60, 70, or whatever it is. If 70 is the total got for the entire semester, if 70 is this much means 100 is how much, like that you can do calculation, right?
Yes, sir.
So for 7 experiment, we don't know whether you are going to do 7 or 8. If 8 is available, we will do 8. Okay, if 7 is available, we will do 7. We are searching for some kind of what you call learning resources online. If nothing is there, keeping the only you remember, if I show only this much, only this PDF file, or how much you can understand. That also you have to think, right? Only from this photograph, understanding everything is difficult. So
Yes, sir.
so we are trying to search any material is available online, and if it is available, that we are going to show it to you, so that you will be having a better understanding, and based on that, you can easily do the calculation. So you are understanding, writing down the numbers in the tabular column, and then writing the Viva examination. Viva examination means only asking elementary questions from this kind of. You can always ask, right? Define moment of inertia. Write down the formula. What will be the dimensions? Define flywheel. This kind of small questions. So if you are able to write it, then based on these things, we will give marks for each experiment. That will decide your final grade. That's all.
Okay, sir.
That's also it's going to be quite simple. But if you totally don't do anything, and without doing anything, if you keep quiet, then there is we don't have anything from your side. Then only trouble will come. Okay. So you try to finish this, and then you upload the your PDF file, whatever number you have written, and that is enough. Any other doubt? Nobody else is asking. 40. How many are there?
Sir,
Somebody else. Yeah.
sir, I have one more doubt. So we will be writing this experiment with the same sample uh, procedures given by Muthukumar sir today, sir. So we will be writing like that, right?
Yes. Correct.
Yes, sir.
I think Muthukumar sir has given you some readings also, right?
Yes, sir.
That is possible because see, when in this experiment, you try to collect the reading from the simulator.
Yes, sir.
Okay, if it is not working, that is different. I don't know how the values will come. If it is not there, then we will try to provide some numbers. Then I will give the numbers. These experimental values I will give. Then you can do the calculation. Okay, but I just started with this apparatus because the simulator is available. That is why I am doing this experiment. I will send you the link, so you go to that simulator and then collect the you make the measurement and write down.
Okay, sir.
Okay. And that's also in another lab we will meet with different experiment. I think next two labs already Lata madam and Muthukumar has written, they will take, right? So after that I will come.
Yes, sir.
Okay. So if there is any more questions, anybody else, you can ask. Some people have joined late. Okay, so you can discuss what happened during this time. Some of the people almost joined in the last minute, 10 minutes before. So is it okay then? Shall we close it? Yeah. So I am closing it. Okay.
Okay, sir.
Okay.